Hello guys, today I'm gonna show you a really boring video about how to do better support options to get a much cleaner object with as less post-processing as possible. Like this, I don't know if you can see it right. This is the object I'm gonna try to explain you how or what settings I use to print it. As you can see by the supports right here. This is the, I printed 3 of these. They all came quite alright. As you can see on this video, the print part came out really easily. Hello guys, today I'm gonna try to explain you how to print complex objects that need supports, unless you have an Ultimaker tree, of course. But this object, for example, was a challenge from Dimensional because he printed this on Ultimaker 3 and I told him that I was able to print this on a single head printer like the ones I have. So to do this, I had to use quite a few tricks on the supports, and if you see the G code, you will see that most of the stuff is quite common, but there's a few buts. So for example, first of all, I print, as you can see by the color, everything around 30 millimeters seconds, which is quite slow for what I used to like to do. Here you have the supports. They are all printed as much as possible as one unit, so you have a much solid structure if it gets hit by the nozzle when travel occurs, which is something that can happen. And also I use dense supports before the print part starts, and I leave exactly one layer in between, which in theory should make an ugly look, but it doesn't, because what I try to do is to first print the most linear thing on the object on the opposite angle of the dense support. So as you can see, I don't care much about the round part of this object, but this thin horizontal, in this case, lines that go along the circle, etc. So also the jump between each layer is 0.8, which allows to get very small jumps in between. So when you print, in this case, this is the start of the tubular thing of the object. In this layer, from this layer to this layer, the jump occurs while there's enough filament on the previous layer, so only one layer is almost printed in on the air. But because all the inside is being printed before, the line prints fine. Also, of course, I must say, I have a very powerful fan setup to avoid as much as possible that any of the two parts glue together, and that's also, there are many parts that I might forget to even explain, but I want to give you a glimpse of what I do to print really complex supports. So first of all, I use a lot of horizontal expansion. I will show you in a second what is this. Horizontal expansion, support expansion, is this. You can see it expands the area on which the support will occur. This is a video I made changing the settings. You can see the more expansion around this donut thing, the more the support expands and try to support something. So first I use that. Second, I use a very high amount of support density. In this case, it's around 35. If I remember well, the default is around 15, 25, something like that. As you can see here, I use a 1 millimeter extra inflation distance, which is this thing I just showed you, is the horizontal expansion. Then I use a 6 dense support layers, which is this that you will see in the slides. Here's the support, then you have the change to feature. The support, then you have that dark gray area that is the dense support. And over that, with one layer of separation, so they don't stick together, it goes the printed area. Then, the other setting is 90% for the dense infill percentage, which is the amount of, let me show you this video, dense support density, yeah, this. As you can see on the dense support density, you use too low, you leave a lot of gaps, which is not good for the objective. My objective was, from the beginning, to be able to separate the print and have it as good looking as possible without any post-processing, which is, you know, what we all want to do when we print. The other setting is, of course, well, you don't need to touch the print support of course, you want it every layer. The other setting is this, the horizontal offset from part. By default, you have a 0.6 millimeters distance. That's okay for most stuff, but not when you are trying to print a circle and, well, a cylinder, a tubular cylinder in this case. Because, let me show you horizontal separation. As you can see, with this value, changes the horizontal plane of the support, so it goes closer or further away from the print part. This helps to avoid both parts being printed as one or fusing when they are being printed. It is something that can happen if you set it way too low. So as you can see in this print, the distance is just barely enough, so when the next layer goes, they don't touch, as you can actually see, but also it has something very thin to be supported by. It's a concept. It's a complex concept to explain. It basically it works. So the next thing one need to adjust to get as clean supports as possible is the support pillar resolution, and this is something that many people neglect to touch. By default, you have 4, 3. This is really important, because to see this, how it works is by doing this. Let's go below the object and use the this, and you automate it. As you can see, there are a lot of small points of, in theory, 1 millimeter that will check where the support needs to go, or, and as you can see, basically this, if you set it to high, in this case 4 is way too high, this will limit the areas of support and will make an ugly print, because if we use this for this size object, you will have unsupported areas that are really key, because you cannot print a curve on the air while shifting the angle, which is something, it's impossible. The print won't be curved. You will have a straight line if you're lucky, and it will look really, really bad, because as soon as you have one bad layer, the next layer will start to look better, but you will have that ugly bottom on the print that we try to avoid. So try to remember to use a good resolution for the object, because sometimes, as always, it really depends on the object you are going to print. So you have a nice resolution for the way Simplify3D thinks about the sports, and you can actually get a really good support on the areas that are impossible to print on the air by themselves. So, like, for example, this curve. As soon as you have this curve really nailed, you can build up from there. The next layer, the jump, because my layer resolution is 0.8, will be very, really small. And also, another thing really important, as you can see on the third layer of this cylindrical donut, I have a lot of perimeters. This allows me to, you can see here, let's go by line. This allows for the printed part to cool, because we are printing really small, really slow, layer by layer. Every layer has support over a layer adjacent, or is touching another layer, so everything becomes one, as a matter of speaking, and you don't have and you have as much quality as possible. Other really important setting, part of the amount of perimeters, that in this case, for something like a cylinder, you need a minimum of 3, and I will use 4, maybe 5 if possible, just because when you break the most complex area, there are these 3 layers. These very first 3 layers are the most complex and the ones that will be most visible, because the next layers, the jump and the angle in between them is really small, and they don't even need support, as you can see here. All that area after that 3-4 layers, it's unsupported. It's just your fun, in this case, my fun, making the work. So, other important setting to control is this print island sequentially without optimization. This is key to get a nice print, because if you deactivate this, you will have, let me show you, you will have the nozzle hitting over a just finished layer over and over, instead of jumping to the next. So you will print A, B, C, C, be A, B, C instead of A, B, C, A, B, C, A, B, C. So you get the idea. By doing A, B, C, C, B, A, you are getting overheat on the A and on the B. If you're lucky, because sometimes this is random, you will have a perfect uh, one. One will be perfect in the middle, but that sucks. You want to have the three perfects. So you want to have a print layer order that is not optimized for speed, but for quality. So when it does one, goes to the next, and then goes to the last, and then starts with the next. It doesn't, because to save time, Cura Simplify3D by default, what it does is to do A, and then B, and then C, and then changes the layer height on the set and prints again over the D. So the time that each part gets cooled down is different. So you will have worse quality, especially when you are printing really complex overhangs like this that are supported. You need as much cooling as possible. Not just by fun, but you need to leave the material to cool down. Okay, this is a boring video, you know, guys, but I'm trying to, I'm trying to give you some of my knowledge. I will show you another example of stuff, because this is really easy. This is an object I just made up, okay? It has circles on the air and you cannot print it. And because, for this example, I want horizontal structure integrity, no, I don't want to print it upside down because the strength of the part will be lower. I made this object, and when I did it, I separated the parts so I can work the supports on different angles. And why this is important? This, yeah. As you can see, these two lateral sticks get a support that goes vertically and the bottom goes horizontally. I do this just because when you're printing an object, let's change the filter type, this print area goes on a different angle as the support. You should try to avoid printing an object on the same angle as the support, because it will fuse one with the other. Why? It just does. I mean, when you're printing objects on the same angle, even in this case the support is an object, if they share the same angular distribution, they are more likely to get fused one with the other, and it will be much harder to separate them, and you will have to post-process the part. If the support is solid enough, like in this case is 6 layers of 0.8, this will split because the support is one object with one structural shape, and the print part doesn't share that angle and it's part of the other object. So it will be so easy to split them without almost anything. You might have some tuning, but it will look really nice. So by doing this trick I will explain in a moment, you can actually customize the angle of the supported, of the dense support. In this case, as you can see, the bottom prints nicely on a different angle. So the trick is really easy. First, you need one process with the, let's remove this DOM, this really bother me. Okay. We have the print process, let's call this print. Here we have the support 90 degrees, and here we have the support 0 degrees. I'm gonna save this to share it with you guys. This support. So, as you will see on the file that I will put down below on the description, as you can see on this support, it has 0 infill, 0 top layers, 0 bottom, 0 outlines, and of course, paint island sequencing without optimization. And for the other object, we have the same. We have no infill, not top layer, not bottom, not outline, just support. This means that this tool process will give you this error. It will tell you, you're trying to print twice the same model, and you don't give up. Don't worry. No? You just click this, and you will see that the two processes, the support processes are working, doing the supports for the objects you need, and in the angle and orientation that you need, which is really something really cool. I just found out today or the other day, I don't remember. I was playing with the idea and it just came to me. The problem is that when you make the object, you actually need to remember to be able to split the parts. Just save them separately. This is a lame example of what you can print, of course, but I wanted to show you complex round supports like on the other object. And that's it. If you have any question, contact me on Twitter or on the Ultimaker forum. I'm there every day. And